playing the video. That was a glimpse what we do at KIY. Now, I would like to invite our student coordinator, Mr. Avinash, to share his journey with KIY Foundation. Over to you, Avinash.
Okay. Good evening, everyone. Respected dignitaries, mentors, and young leaders. I am Anvesh, one of the active student coordinator of KIY. I am delighted to share my journey with KIY. My journey with KIY being in 2025 when I joined as a student coordinator for the Kalam Space Convention. It was a wonderful opportunity that introduced me to leadership, teamwork, and event management. Working closely with students, coordinators, and mentors helped me build confidence and develop a strong sense of responsibilities. Another significant milestone in my journey was being a part of exclusive team for Vignan Vivo 2K26. This opportunity greatly strengthened my leadership and communication skills. I taught me how to interact with different people, work collaboratively as a team, and achieve common goals. Every challenge I faced became a valuable learning experience that helped me both personally and professionally. As my dedication and hard work, where I recognized it was a incredible opportunity to pursuing an internship at DRDO Kanchanbag, where I am currently gaining a valuable practical knowledge and industrial exposure. I sincerely believe that and the guidance, opportunities, and constant encouragement I received through KAY play a major role in helping me achieve these milestones. Today I am proud to stand here as a part of STAX. I would like to express my heartfelt gratitude to KY, my mentors, and everyone who believe in me and support my journey. I would like to extend my sincerely and heartfelt thanks to my respected mentors, Dr. G. Satish Reddy sir, former chairman of DRDO, and Naresh Nyan sir for their constant guidance and encouragement and unwavering support. You beneficially in my potential valuable mentorship and continuous motivation have played a crucial role in shaping my journey. I'm truly grateful for the opportunities and trust you have placed in me. I look forward to continue to learn, contribute, and inspire others through the opportunities that lie ahead. Thank you all. Thank you. Jai Hind.
Thank you, Avinash, for your dedication towards KIY. I know, guys, you guys are eagerly waiting for this moment, the moment we have all been eagerly waiting for. It's my immense honor and privilege to introduce our guest English speaker for today's session. Defense scientist, visionary leader, inspiring women across the nation, Dr. Manimozhi Theodore ma'am is an outstanding scientist, nearly 38 years of service in DRDO. She has begun her journey at Electronics and Radio Development Establishment and went on becoming the first woman director of the board Central for Artificial Intelligence and Robotics and the Defense Bioengineering Electromedical Laboratories. Throughout her remarkable career, she has made significant contribution to artificial intelligence, robotics, defense communication systems, command and control technologies. During the COVID-19 pandemic, her leadership played a key role in developing medical oxygen plant, telemedical systems, and biomedical technologies that benefited hospitals across the India. She has also strengthened international collaboration by signing the first Indian-Japan DRDO robotics of understanding, and her outstanding contribution have been recognized with several prestigious awards, such as Mahila Vijaya Puraskar. Today, she is joining with us to share her insights on life support system by DRDO for Gaganyaan. Friends, please join with us to welcome for joining us the today's session. It is great pleasure to have you with us today. We are excited to learn from you. All the virtual stages over to you, ma'am.
Thank you. I request you to play the video first.
Sahasraka?
Welcome you all. My talk is on indigenous human life support system for Gaganyaan. Please present the presentation. After the JPEG image. Yeah. Next slide, please. So, indigenous life support system for Gaganyaan. I just want to say what is this Gaganyaan program by ISRO. As per ISRO website, the Gaganyaan program envisaging undertaking the demonstration of human space flight to the low Earth orbit LEO in the short term and will lay the foundation for the sustained Indian human space exploration program in the long run. The objective of Gaganyaan program is to demonstrate indigenous capability to undertake human space flight mission to LEO by India. As a part of this program, 2 unmanned missions and 1 manned missions are approved by Government of India. Next slide, please. This one, human life support system, by DRDO, we are contributing to continuous wearable crew health monitoring system, that is by DEBEL, one of the lab I have added, and medical kit, astronaut, food and accessories, fire suppression system, ANC headset, radiation level monitoring systems, and crew model parachute system, emergency survival kit, and the life raft or dinghy. Actually, the last 2 will be used in the re-entry by the crew while they are landing. These systems, DRDO laboratories have signed a MOU with ISRO for the development of these systems. ADRD Agra, DEBEL Bangalore, DFL Mysore, TBAS Inmas, CIFIS Delhi, DLJ Jodhpur, and TBRL Chandigarh. And of course, the CEMILAC will be giving the support towards the standards for these systems. This is the whole Gaganyaan systems will be costing around less than 10,000 crores, but the DRDO development systems are signed for the development cost of less than 100 crores. Next slide, please. I first wanted to talk about the continuous wearable crew health monitoring system by DEBEL. Next slide, please. You know that real-time monitoring of astronauts of Gaganyaan, called Gaganets, is mission critical. The health is mission critical. The crew model monitors the physiological changes, transition during the 0G, maybe for space motion sickness, sometimes it may happen organ swelling or heart arrhythmias. Sometimes blood distribution changes, more in blood volume delivered to heart and upper portion of the body, and hypoxia criteria and temperature variations. The figure shows a simple model for under study initially, where the ECG are monitored, even SpO2 you can see through the finger on the space, and the temperature of the body is monitored, and it's continuously monitored, and through a interface unit, it has to be downloaded to the ground station for the crew and crew health. That is actually handled at the ground by IAM. Next slide, please. Actually, the space requirements are we should have a redundant solution for crew health, and it should have a weight constraints, and it should be lightweight. And few monitored parameters are ECG we have to monitor, heart rate we have to monitor, SpO2, oxygen levels in the blood, skin temperature, and respiratory rate we have to monitor. And these wearable health monitoring should be certified for electrical safety, patient safety as per standard. And it has to be validated for the functionality. All components should be space grade. Materials should be qualified for space applications. Actually, DEBEL, this one is, even though it is initially taken, this study of development of health monitoring for the crew, because of the initial models are having heavy was felt by the astronauts. Even now, industry developed indigenous industry developed health monitoring systems also under study by ISRO. Next slide, please. The medical kit is from INMAS. What has been, next slide, please. We have comprehensive medical kit for the crew, and this medical kit for the emergency survival kit will be after landing on the return path. And actually trash bag and personal hygiene kit also is planned by the INMAS. This medical kit should have the consideration. Few examples are transdermal patches and the pre-filled auto injectors for the injections, and tablets for the mild allergies for ENT, and actually for sleep regulations. Anxiety alertness sometimes are felt by the astronauts. So the sleep regulation, anxiety alertness, for that also we need tablets are included. And for the respiratory dysfunction, if any, these respules with dispensers also may be considered. Some are eye drops for ophthalmologic drugs are also considered. And of course, skin allergies may happen. These are all by the studies. Generally, any astronaut may go through in the space. Next slide, please. Of course, the food is in advanced stage of development, because the previous astronaut from India, Rakesh Sharma, when he landed in the space, in the spacecraft, of course, it is not indigenous. He used Indian food that is provided by DRDO. So, astronaut food development is by DFRL. That veg and non-veg are considered food for with respect to the parameters like protein, fat, carbohydrate, even fiber. Omega fatty 3 acids are also considered for selecting these foods, and they are packed, and water pouches are also included. Studied whether we can do the cutlery as well as warm heaters and trash bags. This initially was developed by Mysore lab. It is also because space missions always consider these things by alternative sources also. I understand CFTRI also is considered for this food at present. Next slide, please. Fire is suppression systems are very important in the spacecraft. So, what is automatic fire suppression systems, either by and also maybe operated by ground control, are also considered for these fire suppression systems. Some are crew operated fire suppression systems also are designed initially by CIFI's DRDO lab. Next slide, please. Yeah, the picture, the video what you have seen is one of the RTRS test for the parachute systems. We see the parachute system is developed by ADRDE Agra. It is in advanced stage of testing. Most of the testings are completed. Advanced stage of acceptance for the crew. This is the system. Out of all the systems, it is in the very advanced stage. You can go to the next slide. You can see many of the material available in Gaganyaan website, ISR website regarding the parachute system. The parachute system consists of 10 parachutes. Apex cover separation parachute is the first one in the re-entry will get open. And this opening module is by the control of ISRO. The parachute is designed by DRDO Agra. And almost the re-entry of 10 kilometers, that the first apex cover parachute will be opened up. Subsequently, the speed will be very high on re-entry. The different parachutes, that 4 different parachutes consist of 10 total systems are used, including redundancy. The drogue parachutes reduce the speed. The pilot parachutes are first opened up. Subsequently, they open the main parachutes. These parachutes are tested by 2 things. Next slide, please. One is called drop test, another is called RTRS test. We will see that the first one what we saw before the lecture is the RTRS test. Then I said emergency survival kit. This is developed by DEBEL, and it is generally used other than astronauts by the Navy. So this is some of the survival items in the naval ESK, which may be considered for the ESK for Gaganyaan astronauts. So water pouches, sometimes when the waters can be used, seawater can be desalted using a desalting kit, and it can be used. That's what I have put there. And it can be considered, need not be considered. It is for redundancy. And food and emergency ration is also included, like chicky bar or badam bar, on high protein bars on return to after landing. And the emergency kit, the Navy kit has the fishing kit also, and it has shark repellent. It has first aid kit by suppose they are landing. Then it has salt and sugar. It has heliograph to say the signaling to the nearby rescue teams, so that distress signal, then mini flares which lights up in the sky, so that the nearby our rescue or the recovery module team will recover from Navy or coastal guards can see. And aviator watch with the compass also used in the survival kit. And goggles are there as eye shield, and the Swiss knife and the flashlight depends on if the night they are landing. And they have a life raft called 3-man dinghy. This is the initial design for the prototype for specification purpose has been developed by DEBEL, the 3-man dinghy. It has a personal locator beacon where you can show the some kilometers distance. They can see where the astronauts have landed in the sea. It is on the as such this raft itself is a redundancy item, because the orbiter module when landed itself is safe enough for the astronauts for recovery. Next slide, please. The parachute testing, the drop test and RTRS test, 2 or 1 is for the drop test. Different drop tests have been done. You would have seen in the ISRO sites. Recently, this week also, they have done an integrated drop test using Chinook also sometime back when integrated test has been done. This is a main parachute test has been done near Agra this week. And that is for the height of the entry. We can 3 kilometers height drop tests are there, and lower heights also we can test using some higher flying like C-17 aircrafts. You can even test at 10 kilometers height drop test. Actually, there is one abort module test has been carried out by ISRO. Recovery module that time was the dummy spacecraft was tested. That time the total parachute system, integrated parachute system was tested, but still all the 10 parachutes, 4 different types of parachutes will go through this drop test as well as RTRS tests. Now I was privileged to participate one of the drop test in IL-76 aircraft. That drop test, similar drop test, from Jhansi, the video we can see there are so many drop tests. This is after the systems drop test has been done in the drop zone. We were all as a team from HSFC, ISRO, DRDO, ADRD Agra, as well as defense team. In the drop test, we are inspecting the parachutes. Now I like to show the drop test video.
Sahasraka, I would like to I request you to play the video.
Thank you. I invite questions now.
Yes, ma'am. Thank you for sharing in detail, ma'am. With your permission, can I ask, I request students to post their question, keep them clear, simpler, and topic relevant. Ma'am, with your permission, can I have the questions, ma'am?
Sure, go ahead.
Ma'am, this question is asked by Preksha. What is your vision for India's defense and space sector by 2047?
That is our own space station, India indigenous space station.
Yes, ma'am. The next question is asked by Jayant, ma'am. How are parachute tested before a mission, ma'am?
They are tested in simulations, and they are in RTRS testing. They have done for speed and angular also. Every RTRS test will be tested for three things. One is minimum speed, maximum speed, and angle of opening. And before that, when we are designing itself, they are designed with simulations, FE modeling, like that.
Okay, ma'am. Ma'am, I'll proceed with the next question. What is the purpose of the parachute system in a space capsule, ma'am?
While the spacecraft is returning to Earth, it comes with a re-entry of very high speed. At the about 15 to 10 kilometers, it re-entered the our Earth's atmosphere. So it has to slow down for the safe landing. When it is landing, we want absolutely as like a ball or a, what do you say, much softer landing. So that is done by the parachute system.
Thank you, ma'am. The next question is how are parachute tested before the mission, ma'am? Like at what speed and how do you calculate the altitude?
Yeah, there are two main tests are there. One is by the height, because 10 to 15 kilometers I said, and it comes stage by stage, 4 stages, the speeds are reduced. So that's why one is drogue parachutes, pilot parachutes open up the main parachutes. So this system design, when it is they are high, with each height they are tested by the drop tests regarding the height is concerned. So with the different aircrafts, AN-25, IL-76, now Chinook was used recently this week for, recently one other place, IL-76 this week, and earlier Chinook was used from Sriharikota for the drop test, integrated drop test with 3 kilometers heights. So that is the testing of the parachutes. The real mission is the two unmanned mission and one mission, where we will be testing the exact situation. The speed of re-entry is tested of the parachute is by the RTRS testing, railway track, which you have seen in the beginning.
Thank you. Ma'am, the next question is interesting. When you look back to the entire your journey, ma'am, like dominating defense a research ecosystem in 1984, what gives you the confidence to climb the space, ma'am, and lead?
I have to thank all my seniors who held my hand and pulled me up, probably, and my family and my friends who have not differentiated me. Of course, my juniors who supported me beyond my office hours and everywhere. Of course, Almighty God has guided me.
Like, ma'am, what are the challenges we'll face during parachute launching, ma'am, in the atmosphere?
We should not face any challenges, right? That's why we are mitigating every challenge, and the textbook launch should be there in the mission. That is why it is totally tested. If the speeds are not controlled, the while entering, the with which with the force the spacecraft will be landing, right? So it has to be checked, and if it is not opening up some angles with the re-entry, so these are all the parachute risk. by ADRD. They are the persons who are doing this re-entry one for ISRO from the beginning. So there we are in the advanced stage of parachute designs for as well as for spacecrafts, for as well as for the paratroopers.
Okay, ma'am. Ma'am, the next question is, what is the difference between spacecraft parachute and military parachute, ma'am? What is the major difference?
Any parachute is the weight with which it has to handle. Now we are talking about 5.7 ton parachute, the testing of the parachutes were. Actually, military parachute, sometimes the tank drop tests are there, where with parachute we'll drop items in the war zone, disaster management systems also use parachutes we drop in the zones. Here it is very spacecraft, it is we are getting it, the it should is entry is the first parachute is at 15 kilometers, 10 to 15 kilometers from Earth's atmosphere. So the testing is very difficult to test the parachutes. The second one is the opening of the parachute control is like a pyro control. That is totally by ISRO. They are that we will open manually. We can when you eject the paratroopers eject their parachutes as an individual. These are all the difference.
Yes, ma'am. Thank you. The next question is asked by Manikanta, ma'am. How can young engineers contribute to Indian vision of self-reliance in defense technology, ma'am?
Now, many startups are considered in defense. Every DRDO lab and as well as defense, many defense startups are considered. You can check drdo.org. Many LSRB, many research boards are there. You can check them also. Research BAD, they are called Aero Designs, then Army Design Bureau, then LSRB, that is Life Science Research Bureau, like that. Many research boards are there where startups and industries can participate, and individuals also can participate along with academia.
Yes, ma'am. Ma'am, the next question is, what happens if one of the main parachute fails to open, ma'am?
Yeah, that's why redundancy is kept. Out of 3 parachutes, 2 are sufficient. That Jhansi test, what you have seen, it is 2 parachutes only has taken up, saying 1 is failed condition. That is what the drop test has been tested in Jhansi. What you have seen the last video. And everywhere the redundancy is kept. The weight of the parachute, the spacecraft is, let us say, 4 to 5 tons. The parachute is designed for 5.7 tons. And the speed with which it has to handle is, the worst scenarios they are designed for 360 kilometers per hour speed. It is tested, whereas we expect in a cool entry very reasonable speeds.
Okay, ma'am. The next question is, which emerging technology do you think will play the biggest role in the future, ma'am, in wars?
Of course, AI, robotics,
Yeah, ma'am.
digital banking.
What happens if the capsule is spinning during the landing position, ma'am? If it
Uh,
spins.
Spinning. That is the role of parachute system, no? It stabilizes and brings it safe. That is the idea of parachute system. They are tested for that.
Okay, ma'am. Like, ma'am, how does atmosphere density will affect parachute performance, ma'am?
For every of that only ADRD has designed. For every of the conditions in that only, that you can see that drogue parachutes and all has holes. There are different structures, depends on the atmospheric conditions. I understand all the students are interested in parachutes. I am also happy it is accepted by ISRO for the Gaganyaan mission, even though many other systems, almost eight systems, we have signed the MOU. This is in the advanced stage. Next is the food, of course, by the end.
And the next question is, as a woman scientist who worked in the challenging field, what obstacles did you face, ma'am, and how did you overcome them?
Man or women, it is the challenges are there. You take it as a, instead of bottleneck, you can take it as a growth thrust. One. Second one is you feel, see, wherever you are going and the trial grounds, you are kept separate. For me, in the deserts, I was given a separate tent. Sometimes I feel privileged, sometimes I feel lonely. Other than that, I have to thank my seniors, T.S. Raghavan, and of course my juniors, Sanjeev Gupta in DRDO, who has handheld me in many of the assignments, guided me so that I do not find these obstacles. I thank my husband who has supported me wholeheartedly and picked me up and late night meetings everywhere and supported the family. Thank you.
Yeah, ma'am, now our student coordinator want to ask the question, ma'am. Sahasra, over to you.
Good evening, ma'am. I am Saharsha, a fourth year student. Ma'am, my question is that when parachute deployment is one of the critical phases of space mission, how do engineers ensure a reliable development and control of a parachute system in unpredictable conditions during re-entry?
It is taken care in the design itself. Total design is considering. That is why instead of single parachute handling the 5.7 10 parachutes are used. So 4 different types of parachutes with a redundancy in each parachute, so that 3 main parachutes are kept. 2 is sufficient. That itself is a overdone work. Instead of the spacecraft, maybe 4 to 5 tons only, but the capacity of the parachutes is 5.72 itself. But 3 parachutes are designed, and that is the redundancy. And they are tested and designed for all kind of weather conditions by ADRD, who are in this area of parachute design. They are in the designed for long time, and their parachutes are used earlier itself for SRE missions of ISRO.
Thank you, ma'am.
Yeah, ma'am, the next question is, during the COVID-19 pandemic, what were the major challenges in developing PSA oxygen plants and N95 marks, ma'am?
Yeah, I think it is because I was DEBEL director. I think I requested their coordinator asked for a separate lecture. It is we have to thank our that time chairman Sadish Reddy sir, who has kept DEBEL in a very priority place during the COVID-19. The challenges were many. I have to thank my DEBEL team who has come along during the total lockdown. We worked day and night, traveled across the country. Most of the team members also developed. First time we could develop by N95 mask, tested in Chitra, Coimbatore, and certified it. And we have mass produced and delivered. And we were as DRDO, we have developed PPE kits, and many industries participated. Extreme challenging situations only. Many of the people who traveled across, we have taken, even though vaccines, many of our scientists also affected by COVID. Yes, it was really challenging and satisfying also that we are working in the nation building and emergency empowered group. As DEBEL director, I was member of empowered group of nation. Yes, I was reporting directly to our chairman that time, Reddy sir. Had a very satisfying tenure serving the nation.
Yeah, ma'am. Now, as student coordinator, Hasini wants to ask you the question, ma'am. Hasini, over to you.
Good evening, ma'am.
Yeah, proceed.
Good evening, ma'am. I'm Hasini. As a student founder building an IoT based agriculture platform, what would you recommend as the first step to validate and scale technology solution using space based data and industry collaborations, ma'am?
I think this question to be routed to ISRO.
Okay, ma'am. The next question is, ma'am, during your 4 decades journey in the science, ma'am, which project or achievement gave you the greatest satisfaction, ma'am? Like,
All the projects gave me a greatest satisfaction. Either they are in the design stage, nor so that subsequently they are taken up by the juniors to many important assignments. Some are in the testing stages, in the desert trials and all. Yes, with the interaction with user, when the user accepting our equipments, it was very satisfying because that is a mission of DRDO, Defense R&D. So when our defense users accept that, it was very satisfying. When I was working for DEBEL, Biomedical was very satisfying because we are working for the many of the indigenous development of the systems in the medical side, above knee prosthesis, and as well as some of the for the handicapped people like that. That is also was satisfying assignments. COVID, of course, COVID biothreat mitigation projects for as an empowered group during COVID was serving the nation was a very satisfying assignments.
yeah, ma'am. Next question, I would like student coordinator Soumya want to ask the question, ma'am. Over to her, ma'am.
Good evening, ma'am. I'm Soumya, a final year EC student. Ma'am, today students have access to advanced technologies like AI, IoT, and robotics. If you are an engineering student today, which technology would you choose to master for contributing to India's future defense and space missions?
Of course, robotics, because I studied robotics in IISc System Science and Automation. Even today, I will go for advanced robotics.
Thank you, ma'am. The next question is, what role does technology will play in making Gaganyaan successful, ma'am?
Yeah, totally. Space technology is complex, isn't it? It plays a very important role because Gaganyaan is not the final by ISRO. If you see the ISRO websites, you can see that is the start of the human space flight centers assignments. And future in India's space station as also as a vision of India. Yes, that plays a very important role.
Ma'am, the next question is, how important is cybersecurity in modern defense communication system, ma'am?
Very important. Cybersecurity is very important because that is the backbone of safe communication of all defense communications should be safe. So that delivery of our networks are very important. Basic. It's a basic requirement.
Yeah, ma'am. Ma'am, the next question is, what are the key areas where India still needs to do more innovation in defense technology, ma'am?
Yes, we have to have our own wafer development if you take uh, silicon wafer development so that no malwares are there in our systems. So totally that should be indigenous. We can say first, so that total systems should be indigenous for the, even though everybody assures in writing, we do not know, many of the network systems should be indigenous. Yes, so many and so forth.
Yeah, ma'am, this question is asked by EC graduate. Which subject will help us the most in the career, ma'am?
Any subject with you are passionate about is will help our career. You have to go in depth of your subject. Every subject has potential in life and career.
Yeah, ma'am. The next question is, what is the difference between engineering and a scientist from the experience, ma'am?
Yes, research ask everything question. So engineers take from what is most of that as accepted, you build above it. As a researcher, I ask every fundamental one also, I ask the question. Even though it is accepted, I start asking the question. Yes. Until we find the answers, we will ask question and verifying every answer as a researcher. And you can see, even though the many of the systems are tested for the functionality, tested again and again, they are tested, isn't it? If you see the drop test of that one, this is the integrated drop test itself, 2 times have been conducted, correct, by different heights for different one test is sufficient, say that simulation may be sufficient as an engineer, but R&D you want a thorough testing, and of course questioning, is this material or different materials are required, like that. So you ask fundamental questions. Yes.
Yeah, ma'am. Like one of our student from 8th grade has joined the meet, ma'am. Harit Kumar, want to ask you a question, ma'am. Over to you, Harit.
Ma'am,
Good evening.
how are you, ma'am?
Great.
I'm from ZPH Dhanmajpet School.
Go ahead with your question.
Ma'am, ISRO is when developed. When you researched on which?
Yeah, I worked in communication intelligence, my research, cybersecurity, of course. Then subsequently, I worked in robotics, then biomedical, and for Gaganyaan life support systems. Yes,
Oh, ma'am.
and leaderships. Thank you.
Thank you, ma'am. And this is the last question, ma'am. Who inspired you to choose a career in science, ma'am? And what motivates you to continue this journey, ma'am? As a students, we want to know.
No, I can say my brother, B.S. Ilangovan, my elder brother, wanted me to study in science and take up a job in DRDO. That time, I do not know. Even when I joined, I got appointment order in LRD and joined. I do not know what is DRDO. Yes. And subsequently, I had opportunity to work with Kalam's projects and many projects. Every one of the projects were inspiring. I worked with 2 great people. One in my communication, one was N. Sitaram, Command and Control Systems. He has inspired me a lot. And of course, Dr. G. Adityan, cybersecurity. He has inspired me a lot. Many people. Yes, thank you.
Ma'am, the student who has joined, he was from government school, ma'am. He is very enthusiastic in space, ma'am.
Yeah, there are many. Once you complete your this one, many fellowships are there. Student training programs are there in engineers. Student school training also. I heard ISRO is conducting. You can join. Try.
Ma'am, we are having many questions, but the last one question, ma'am, with your permission.
Go ahead.
If you could give one piece of advice to younger self in emerging students, what would it be, ma'am?
Concentrate and focus and put all your effort in that direction.
Okay, ma'am. Thank you, ma'am, for answering patiently all the questions, ma'am. Now, I would like to invite Mr. Sriraj to deliver vote of thanks. Over to you, Sriraj.
Yeah. Good evening, everyone. It's my great pleasure to deliver the vote of thanks for Extract Lecturer 16. First of all, I would like to sincerely thank Dr. Manimozhi Madam, former outstanding scientist and scientist H at DRDO. Madam, thank you for your wonderful lecture on Indigenous Life Support System by DRDO ISRO for Gaganyaan. Today's section gave us a valuable knowledge about the advanced technologies that keep astronauts safe during the space mission. We learned how DRDO has developed Indian-made systems for oxygen supply, carbon dioxide removal, temperature control, and emergency life support. The session showed the India's commitment and self-reliance in space technology. It inspired to appreciate the hard work of dedication of our scientists, engineers, and making this Jagannath vision reality. Thank you for your sharing knowledge and motivating us learn more about the space technology. I would like to thank the KIYE Foundation for organizing Extracurricular 16. This program gives students a wonderful opportunity to learn from experts and gain knowledge beyond the classroom. My sincere thanks to the organizing committee, coordinators, and technical team for their hard work and excellent arrangements in this make today's lecturer success. I also thank the students and participants for attending the session and making it meaningful and its presence and attention. Finally, on behalf of everyone present here, I once again express my heartfelt thanks to the Dr. Manimozhi Ma'am and KY Foundation for inspiring and informative session. Thank you all. Have a wonderful evening. Jai Hind.
Thank you.
Thank you, ma'am. Thank you for joining us and making the lecture memorable. Thank you, ma'am. To end of the session, I request all the participants to please join, subscribe our YouTube channel, follow our LinkedIn page, and for more updates, be connected with us. Thank you, guys. Thank you for participating. Thank you for sharing the questions.
Yeah, thank you, ma'am.
భవానీ లింక్ గ్రూప్లో పెట్టి అందరినీ జాయిన్ అవ్వమని చెప్పారు అవి
Okay.